Question number 6. The parametric equation of the curve are x is given and y is given in terms of t, where t is greater than negative 4 over 3. Show that the dy over dx can be expressed in the form of c times 3t plus 4. I state the value of c. Okay, we need to find the dy over dx. And we know that by chain rule dy over dt is equals to dy over dx times dx over dt. To find the dy over dx is equals to the dy over dt over dx over dt. To find dy over dx, we need to find the dy over dt and dx over dt. And first we find dx over dt. dx over dt is equals to the derivative of 2t plus 1 over 3t plus 4 with respect to dt. Okay, we can apply quotient rule, which says that derivative of u over v with respect to t is equals to the v square, v derivative of u minus u derivative of v. So in this case, this one is u and this one is v. So dx over dt is equals to the 3t plus 4 whole square, and this will be remain same here. Then derivative of 2t plus 1 with respect to dt, then minus, then 2t plus 1 multiple, and then derivative of 3t plus 4. Okay, now let's solve it. This will be equal to 3t plus 4, and derivative of 2t plus 1 is 2 minus 2t plus 1 times derivative of 3t plus 4 is 3 over, and this one is also in fact 3t plus 4 whole square. When we solve it further, we will have 6t plus 8 minus 3 times 2t, which is 6t minus 3 over 3t plus 4 whole square. So dx over dt is equals to the positive 6t cancel with negative 6t, and we will have 5 over 3t plus 4 whole square. So we have calculated the dx over dt. Now we find dy over dt, derivative of y with respect to t, derivative of 2 ln 3t plus 4 with respect to dt, and this will be equal to the 2 derivative of ln 3t plus 4 is 1 over 3t plus 4, and derivative of inner value is derivative of 3t plus 4 with respect to dt. When we solve it further, we will have dy over dt, which is equal to 2 derivative of 3t plus 4 is 3 over 3t plus 4. And when we solve it, it will be 6 over 3t plus 4. And this is dy over dt. We have calculated dy over dt, derivative of y with respect to time, and we have calculated the derivative of x with respect to time. Now we can find dy over dx by plugging these two values in this equation. So dy over dx is equals to the dy over dt over dx over dt, and dy over dx is 6 over 3t plus 4 over 5 over 3t plus 4 whole square. So this square will be cancelled, and we will have 6 over 5 times 3t plus 4. So dy over dx is equals to 6 over 5 3t plus 4. So we have calculated the dy over dx, and the required format was c times 3t plus 4. So c times 3t plus 4, and c is in this case 6 over 5, and we have also calculated the value of constant c, which is 6 over 5. Let's move to the part B. It is given that the gradient of the curve at the point a comma ln 100 is m. Find the value of a and m. Okay, we are given y coordinate is ln 100. We need to find dy over dx at a comma ln 100, and this one is equals to the m, and we need to find the value of a and m. First we substitute y coordinate in y equation to find the value of t. Y is equals to 2 times ln 3t plus 4, and here y is ln 100, which is this one given. Okay, let's find the value of t. So ln 100 is equals to the, by using property, we know that a to the power of x ln is equal to x ln a. We can use this property in this case also. So ln 3t plus 4 square. We can cancel ln, and we will have 3t plus 4 square is equal to 100. Square root both side. We will have 3t plus 4 is equal to plus minus 10, and we have two values of t. So 3t plus 4 is equal to 10. On the other side, 3t plus 4 is equal to negative 10, and this one is equal to t equals to 2. And by solving this, you will have t equals to negative 14 over 3. And this value, negative 14 over 3, is less than negative 4 over 3. And given range of t says that the t should be greater than negative 4 over 3. So this one is less than negative 4 over 3. So we will discard it, as it doesn't satisfy the given range. So t is equal to 0 is applicable. Now by using t is equal to 2, we can find value of x coordinate. X is equal to 2t plus 1 over 3t plus 4, and here t is 2, and we can find the x coordinate. So x is equal to 2 times 2, 4, and plus 1, which is 5, and 3t means 3 times 2, which is 6 plus 4. So this one will be 10, and this one is equal to 1 over 2. So we have x coordinate. This x coordinate is also the value of a. So we can say that this one is a. We have calculated the a. Now we need to find the value of m, and value of m is equal to the dy over dx at a comma ln 100 is equals to m. And we have calculated the derivative of y with respect to x, which is 6 over 5 times 3t plus 4. So 6 over 5 times 3t plus 4 at a, which is 1 over 2 comma ln 100 equals to m. But this derivative is the function of t, and the corresponding value of t for ln 100 was 2. So in this case, we will say that m is equal to 6 over 5 3t plus 4 at t is equal to 2, and we can find out 6 over 5 3 times 2 plus 4, and this one is equals to the 6 over 5 times 10, and this one is equals to the 12. So we have calculated the value of m, which is 10, and a is which is equals to 1 by 2, and m is equals to 12. These are the required values. Let's move to the part C. State whether the curve represents the decreasing function or increasing function or neither. Give a reason for your answer. Okay, to find the function's nature, whether it is decreasing or increasing, we need to find the slope of the function. Or we know that the this is the derivative, which is that 6y dy over dx is equals to the 6 over 5 times 3t plus 4. And when we observe it, it is become 18t over 5 plus 4 over 5, and this is the dy over dx. When we plot this equation is will be the straight line, and this straight line has the slope of 18 over 5. Because the slope is positive, so the given curve will be the increasing function. So we can say that the gradient of the curve is a straight line which have positive slope. That means the curve represents the increasing function. Okay, let's move to the question number 7.